Students, okay, dear student, let us see what is there in this question now. A cell of negligible internal resistance and electromotive force 6 volt is connected to three resistors PQR. R is an ohmic resistance and IV characteristic of P and Q are shown. So these are known ohmic and the characteristic is shown here. Okay, so the graph is shown. The current in P is 0.4 ampere. Show that the current in Q is 0.45. Current in P is zero point 0.4 and Q is 0.45. So P and Q. Okay, so the graph is given here and so you can clearly see that these are known ohmic. Let me explain you what is an ohmic resistance and what is a known ohmic resistance. Ohmic resistance is the resistance that follow the Ohm's law. What is the Ohm's law? V is equal to IR, which clearly means that the graph between V and I will be a straight line passing through origin. So it has to be like this. If it is not this, it is no ohmic. So definitely P and Q graph is coming out to be curvilinear graph between I and V. So that is not good. So this is no ohmic resistances. These are okay. Now the current in P is shown as 0.4 ampere. Here it is 0.4 and you talking about P. So the voltage across P should be, according to this graph, it should be this. What is this value? 1, 2, 3, 4, 5. So it's basically 1.4 volt. Yes. So 1.4 volt is the potential difference across P. 1.4. So 1.4 is the potential difference across P. So that will be across R also. So the potential difference here is 1.4. Total potential difference is 6. Clearly, Q would be having a potential difference of 6 minus 1.4. So 6 minus 1.4 is 4.6. So 4.6 volt is the potential difference across Q. So you want to find the current now. So 4.6. Yes. So voltage is 4.6 now. 1, 2, 3. This is 4.6. And so the current in Q is here. It is this. So it becomes um 0.4. This is 0.5. So this is 0.45. 0.45 amperes. Absolutely correct. This is 0.5 mark. This is 0.6 mark. So this will be 0.45. So clearly we can say that yes, the voltage will be this. So do you get it what I did? Because those two things, they are basically in series. We can say actually they are not in proper series, but as per the potential difference is concerned, definitely this will be having V1, this will be having V2, which will be across P as well as across R, the potential difference. So V1 plus V2 will be equal to 6 volt. And clearly this is the way that we would be doing it. Let us see what they have done. So question number 4, the potential difference across P is 1.4. So the voltage across Q will be 6 minus 1.4. And so this is this, and accordingly we can find the current which is passing through the Q. So that is coming out to be 4.5 amperes. Let us now move back to our question. Uh-oh. Okay. Just a moment, please. I have to get rid of these windows. Okay. So let's go for the question number 2 now. Calculate the resistance capital R. So calculate the capital R. Okay. So we have now created the new data for ourselves. Like the voltage difference here is 4.6 volt, and this was coming out to be, this was 6 volt. So it was 1.4 volt. Yeah. Yes. So we want to find the resistance of R. So the voltage across R will be 1.4. The current we can find, like the total current is which is coming into this, like passing from Q, is 4.6. And the current which was in P, what was the current? We found that current. No, this is the problem with the paper 2 questions. No, like every other time we have to see current in P is 0.4. Okay, 0.4 and 0.45. So the current here is 0.05 ampere, and the voltage across this was, I have forgotten that now. I think it was 1.4 volt. I tell you, these paper two questions, no, like they are not only about the hard disk, like how many formulas that you remember. It's about your RAM also. Okay, so how many things you can keep it here. So it will be 1.4. So the resistance will be 1.4 divided by 0.05. So the resistance will be 28 ohms. So that will be the answer. Let us go to the mark scheme and see if that is the correct answer. And yes, it is indeed 1.4 divided by this. So that is 28. Let us now move to the next question. Calculate the total power dissipated in the circuit. Total power dissipated. So for the total power, we should be concentrating on the battery. That is the power which is given by the battery. So the total power given by the battery will be equal to total power consumed. So the voltage is 6 volt and the current which is coming is 0.45 volt, sorry, amperes, isn't it? 0.45 ampere, the current which is coming from this. So the power formula is V into I. We are concentrating on the power given by the battery. That will be our answer. 6 multiplied by 0.45, 2.7 will be the answer. So 2.7 watt is the power given by the battery, which will be equal to the total power consumed by the circuit. The other method is to first find all of the resistances, then you find the R equivalent or R total, and then you will apply the formula I square R to find the total resistance, total power. So you can use 2.7, like P is equal to VI. It's better if you're concentrating on the battery. So the answer is 2.7. And let us see what is the answer here. Yes, even they have done the same thing. V into I, that is 2.7 watt. Okay, so this is how we do this question. Let us go to the other question now. Resistor P is now removed. Suggest without calculations the effect of this on the resistor of Q. Now P is removed. What is the effect of this on the resistor of Q? Okay, so P is now removed. What is the effect of this on the resistance of Q? Okay, so P is removed, which clearly means that the R equivalent will increase. It will be having more total resistance. See, when the two resistances like P and R, these two resistances, they are in parallel to each other, so their equivalent resistor will be minimum, like it will be lesser than the minimum of the two. So the resistance for P and R will be very less. Later, that resistance will be added into the resistance of Q to create the total resistance. Now, if P is removed in the first place, so R is not going to be reduced. R will be giving you a big value, which was coming out to be, I think, 28 ohm, I think. If it was 28 ohm, so only and only 28 will be added there. No. So R total now will be the sum of Q and R, so that will be bigger. If this resistance will become bigger, it means that the current which is flowing here will become lesser, isn't it? Because the total current will be total voltage divided by total resistance. Now you have a bigger resistance, the current will be lesser. So the current which is passing through Q will be lesser. Earlier it was 0.45 amperes. Now it will become lesser than this. So what is going to happen? Let us go to the graph now. And you can clearly see that if the current is reducing here, so if the current is reducing, the slope is increasing. Like here, the slope was like this. Gradually, the slope is becoming steeper. And now this graph is I by V. So in I versus V graph, the slope of IV graph will be equal to 1 by R. Try to understand. The slope of VI curve is R. This is I by V. The slope is I by V rather than V is equal to IR. The slope I by V is equal to 1 by R. That is why. So more is the slope, lesser is the resistance. So if the current is reducing, the slope is becoming bigger. It means the resistance will become lesser. So even for Q, the slope is becoming like this, isn't it? Like slope is increasing. So the resistance of Q is going to increase. So this is the explanation. Let us go and see what is given in the mark scheme. Q will have a smaller resistance. The slope has increased. Sorry, earlier I said it in the wrong way, but I meant the same thing. Slope is bigger in the case of Q. So the slope is equal to 1 by R. So bigger slope, lesser R. So Q will have a smaller resistance. I think by mistake, in the statement when I was giving earlier, I told it that the resistance would be increasing. Slope is increasing, resistance is decreasing. Please forgive for that. You can also see if I actually made a mistake or not. I don't remember. So this is it. It means that for Q, the resistance will be smaller, but I have given you the correct explanation. Because total resistance of the circuit now will be larger, the current will be smaller. So the slope will be higher, and which means that the resistance will be smaller. Okay, dear students, so this is the explanation for this. I think the question is now over. Let us verify. Yes, there will be question number 5 after this. Yes, so this is all for this question, and now in the next video we would be going for the question number 5. Okay, dear students, all the best. Thanks for joining.